Yes. Welcome back, students. So in the last session, we have discussed about W hash W, how to perform the operation in Turing machine, how to justify the left hand side input and right hand side input is equal in Turing machine, how to perform that. So that we have discussed. In this session, we will discuss about how to draw an automated diagram for this particular Turing machine operation. So we are having two inputs here. One is A, another one is B. So we are having two class of inputs. One is A class of input, another one is B class of input. So we have to divide the path of the automata in two ways. One is for A, another one is for B, in order to justify the left hand side input and the right hand side input. So I am starting with the initial state Q naught. So now you see here, first I'm going to start with A. So A will be mentioned here. So this is Q1. So A will be replaced as X and moving to right hand side. So the next element is BA. So as per the logic, after crossing one A in the left hand side with X, you have to move to the right hand side until you are reaching the hash. Okay. So remaining elements will be represented as it is. B will be mentioned as B and move to right hand side, and A will be mentioned as A and move to right hand side. So you will be having hash here. So mention it as Q2. Then hash will be mentioned as hash and move to right hand side. And you can see here the first A is replaced with X. So mention this as Q3. So this A is replaced as X and moved to left hand side. So remaining elements will be represented as it is. When you are moving this A with X and moving to the left hand side, you are having hash. Okay. So mention it as Q4. Represent this hash as it is and move to left hand side. So what are all the elements you are having? A, B you are having. So you have to move to left hand side until you are attaining the first X. So up to that you have to move to the left hand side. You should not change any other inputs, just move to the left hand side. Okay. Now after moving to the left hand side, you will be encountering the first X. So the first X. Now this X will be mentioned as X and move to right hand side. Okay. Now you are having B. Okay. So we have successfully completed the crossing of left hand side first A and the right hand side first A. Next thing is left hand side first B should be operated. So this B is replaced with X and moved to right hand side. So now again, what are all the inputs you are having the right hand the next to that input, it should be mentioned as it is. What element you are having? A you are having. If it is B, so you have to mention it as B as it is and move to the right hand side. So in this occurrence, we are having only A. So I am for some security purpose, I am mentioning B also, because if the user is inserting B, have another input as A, B. So for that B will be used. So I have mentioned this as a precaution measure. Okay. So B is replaced as X and moving to the right hand side. Now next element is A. A is replaced as A and moving to the right hand side. So what is the element you are getting? Hash. So mention this hash with hash as it is and move to right hand side. Okay. So now what are up to when you have to move to right hand side? Until reaching the first B. So remain, what is the element after hash? X is, you are having X. So just make it as a loop. X is mentioned as S and moving to the right hand side. You are having B. Now this B is crossed with X and moving to the left hand side. And moving to the left hand side. Okay. So now up to when you have to move to left hand side until you are seeing the first X. Yes, this pointer. Okay. So here you have to mention with the loop X is mentioned as X and move to left hand side, and another element you are having A is mentioned as A and move to left hand side. So okay, now you will be having hash here. So actually this will be, when you are replacing this B with X, you have to move to left hand side. You are having X. Okay, this X will be mentioned as it is, and moving to the left hand side, you will be having hash. So this A will not come here. This A will not come here. Just write out this A. Okay, so X will be mentioned as X and moving to the left hand side, and you are having hash. As is mentioned as hash and moving to left hand side, you are having A. Mention this A is as it is and moving to the left hand side, you are having this X. So again, move to this state Q0, X is mentioned as X and moving to the right hand side, you will be having A. Okay, now this A will be mentioned, replaced as X and moving to right hand side, you will be having hash. Hash will be mentioned as hash and moving to right hand side. So what are all the things you will be having? So you will be having two X's here. So what are all the X's is coming? Mention it in the loop. X is mentioned as X and moving to the right hand side. Now you will be having A. This A will be replaced as X and moving to the left hand side. Why we are replacing this A with X? Because the left hand side we have replaced another one A. In order to perform the equalization, we are replacing this X, this A with X in the right hand side also. So just moving to the left hand side, hash mentioned as hash and move to the left hand side. So it will be moving entirely to the left hand side until you are reaching the first X. Here is the pointer. The first X will be mentioned here. So X will be now from this Q4 to Q0. The X will be mentioned as X and moving to right hand side. Now you will be in this state, in Q0 state. So in Q0 state, there is no right hand side means, so after the left hand side X, immediately in the right hand side if hash comes means, so it is representing that in the left hand side no other input to perform. So just draw another one state Q7 and mention this hash is mentioned as hash and moving to right hand side. Hash is mentioned as hash and moving to right hand side, you will be having the state Q7. After that, we have to check any other element is present on the right hand side or not. So immediately after X, you will be having hash, you will be having many X. Mention those X's in the loop and move to right hand side. If no elements are present except blank means stay in the blank and stop the operation. So blank is mentioned as blank and stay halt. So this is the acceptance state. This Q8 is the acceptance state. So this is how we can perform W hash W in Turing machine. So this part represents the instantaneous description for this problem in Turing machine, and this right hand side is represented as the automated diagram in Turing machine. Okay, thank you.